Okay, this is one of your supplementary problems to your textbook assignment. We have a horse attached to a sled by a harness, and then we have a small sled attached to a large sled by a rope. Now, anytime we're dealing with cords, strings, cables, harnesses, these are excellent Newton's third law problems. All right, another part of the given that we're is the tension in the rope between the small sled and the large sled is 250 newtons. The tension in the harness from the horse to the sled, be careful here, it's rated for a maximum tension of 4,500. It does not mean the horse is pulling at 4,500. That is a target value. What we're going to do is we're going to find out what the tension in the horse's harness is and compare that to 4,500, see if it breaks or not. Okay, we can kind of look at this and we can see the 450 newtons, that is the weak link in the chain. If there's something going to break, it's going to happen between the big sled and the little sled long before it happens between the horse and the big sled. So that's where we're going to concentrate our efforts. Let's do a free body diagram of the little sled. Okay, the maximum tension that it can withstand on its rope is 450 newtons. I got a force normal and a force of gravity, but I'm told that we're on snow and therefore we can assume this is pretty much frictionless. So force normal, force gravity are going to cancel out and there is no friction force. So my free body diagram simplifies to just this. All right, I'm ready for Newton's second law. Second law is going to be very easy. I really only have one force of any great significance acting on this. I know the mass. That means that the little sled can accelerate up to 3 meters per second squared before its rope will snap. All right, now that I know the acceleration of the little sled, I can apply that to the acceleration of the entire system. So that means if the little sled is accelerating at 3 meters per second, then that means the big sled and the horse are all accelerating together at 3 meters per second squared. All right, so I'm still frictionless. On the large sled, I've got two forces on it. One, the force of the horse harness pulling on it, and this 450, that's the tug of the little sled behind it. Again, the force normal and force gravity will cancel out, and I'm frictionless. So this is going to reduce to these two forces right here. I'm now ready for Newton's second law. Okay, I'm going to call the force applied by the horse harness positive. I'm going to call the sled tugging behind negative. And I know the mass of the large sled and I know its acceleration. So I can solve for the force on the horse harness. And what I want to do then is I want to compare that to 4,500 and see if it'll break or not.